Good morning. I'm pleased to present our research titled Machine Learning-Driven Approach to Multi-Criteria Decision Analysis Model Automatization. This work is a collaboration between researchers from the University of Szczecin and the West Pomeranian University of Technology. We focus on the integration of machine learning models with multi-criteria decision-making methods for predicting rankings of alternatives based on historical datasets evaluated by experts previously. The practical problem addressed concerns the implementation of Sustainable Development Goal 7 by 29 selected European countries. The proposed approach addresses limitations in classic multi-criteria decision analysis models, namely dependence on the knowledge of domain experts used for assigning the criteria weight significance. This paper presents a framework integrating machine learning techniques with multi-criteria decision analysis, namely MCDA methods to predict rankings based on previously evaluated datasets. MCDA is well suited for assessing data involving multiple, often conflicting criteria, while ML models can predict outcomes for datasets with multiple attributes. The input data for the years 2004, 20, and 22 were obtained from the Eurostat database, and they create a historical dataset. For each year, countries were assessed on their realization of Sustainable Development Goal 7, SDG 7, aims using the critic method to assign criterion weights and the Topsis method. This approach reflects expert-based assessments of historical data. Topsis was chosen for its popularity, broad applicability, and algorithmic simplicity. Assessment results for each country were expressed as score values, serving as the target variable. A dataset covering 2004-2021 with 522 observations was compiled and randomly split into 80% for training and 20% for testing. An additional dataset from 2022 was used for the final evaluation. Prior to applying machine learning, feature values were normalized using minimum-maximum scaling to address differing units of measurement. The machine learning process included hyperparameter selection, cross-validation, model training, and prediction. The multi-layer perceptron regressor model was selected as the base predictive model for this research. 4 reference machine learning models were used for benchmarking with multi-layer perceptron regressor. This research uses models and metrics from the scikit-learn Python library. Hyperparameters for the multi-layer perceptron regressor were selected using GridSearch-CV with k-fold cross-validation, followed by model training and testing. Model performance was evaluated against expert-based multi-criteria results using metrics such as mean absolute error, mean squared error, and R-squared. Tests were conducted on a randomly selected set of 105 samples and a dataset collected for 2022 with 29 country samples. To compare predicted and actual rankings for 2022, the weighted Spearman rank correlation coefficient was applied. In the first stage, hyperparameters for the multi-layer perceptron regressor were selected using the GridSearch-CV function. The selected hyperparameters are displayed in the presented table. Then we have performed k-fold validation using the regression score function to assess the multi-layer perceptron regressor model's performance. Results obtained for each fold are high and close to 1, which suggests good performance of the applied model. Then the performance of the multi-layer perceptron regressor was compared with 5 reference machine learning models. The results show that the performance of the examined machine learning models is high and comparable. Country rankings generated from scores predicted by each machine learning model were compared with the expert-based multi-criteria ranking. The results show consistency across all considered machine learning models in ranking the top countries: Norway, Iceland, Sweden, Finland, Denmark, Austria, and Luxembourg. This is crucial as decision makers are most interested in the top rankings, making model precision essential. The results reveal that all models were highly consistent with the factual ranking, with the multi-layer perceptron regressor and kernel ridge regression models showing the highest convergence. Rankings from the linear regression and Bayesian ridge regression models were also consistent, while the gradient boosting regressor model showed the least convergence. This contrasts with performance metrics presented previously, where gradient boosting regressor had the highest convergence. highlighting that model performance can vary depending on whether scores or rankings are evaluated. This highlights the importance of comparing models for both scores and rankings based on study objectives. The results showed that all machine learning models considered in this research effectively predicted rankings based on previously evaluated historical datasets. Integrating machine learning techniques into the framework addresses the challenge of expert unavailability when evaluating new data, provided that sufficiently large, expert-evaluated datasets exist. Comparative analysis proved to be valuable due to differences in machine learning model outputs, helping confirm strong alternatives when multiple models indicate compliant top rankings. A limitation of the approach is its reliance on historical data, which may delay adaptation to changing decision-maker preferences, introducing inaccuracy. Regular updates to the training dataset and expanding it should be key directions for future research. This work was supported by the Polish National Science Center and the Ministry of Science. Thank you for your attention.